algebra classes focus on the skills, but not on why you need to know these things. So before the end of the year, we will be talking about why one needs to factor, why that's a good skill to know, and how it helps you. So just in general, what does it mean to factor something? Factor a number or factor a polynomial? What does it mean to factor? Yeah? Yeah, some can consider it a form of simplification. Isaac? That's what you were going to say. Now you can factor numbers. So I could factor the number, let's say 6, and 6 factored is 2 times 3. I don't know why I can't like factor that. But that's a factorization of 6. To factor is to write something. Write something as the product of one or more quantities, or 2 or more quantities. So factor means to break down a number in a polynomial into factors, or things that are being multiplied. So 6 factored is 2 times 3, or 6 times 1, or 2 times 3 times 1, or 1/6 times 6. But basically, you're just writing it as numbers being multiplied. So it's like pre-multiplication, what it will look like before it was multiplied. Does anyone know what a prime factorization is? What's the definition of a prime number? Davian? So I'm going to lead you a little bit. A prime number is only divisible by what number? 1 and itself. Good. So a prime number is only divisible by 1 and itself. So I'm assuming that's what you meant by can't be divided. So what's the lowest prime number, you guys? Actually, 1 is not considered prime. Yeah, it would be 2, because 1 is part of the definition of prime. So the lowest prime is 2, and 2 is actually the only even prime number, because any other even number can be divided by 2. So it would be divisible by more than that. So primes start with 2. What's the next prime, everybody? What's next?
7, 11.
Did you skip 9?
Or 9. Wait, no, 9.
You did, but it was a good idea.
13, 17, 19, 23.
I need to do this all day, every day, just come up with a primes. And actually, that's what the people did in math, is they factored everything down to the primes. Yes?
What is 0? Is 0 prime?
So when we speak about primes, 0 can be written as 0 times any number. So factoring 0 is like everyone could have a different factorization. Twinkle could say 0 was 0 times 1. Ashley could say it was 0 times 2. They both be correct, because both of those multiply to give you 0. So factoring 0 is kind of futile. It doesn't really get you anywhere. So a prime factorization, if I prime factorize, let's say the number 40, prime factorize 40. I would be writing it as a product of all prime numbers. So I like to do the little factor trees because they're fun. So I think of, okay, what are two numbers multiplied to give me 40? And the first thing I can think of is 5 times 8. You guys may think of something else, doesn't matter. Then you look at, are these two prime? 1 is, 5 is prime, so you're done with the 5. 8 is not prime, so the 8, you need to continue the factor tree. 8 is 2 times 4, and then 4 is 2 times 2. And then as soon as you hit a prime, you're done with that branch. So the prime factorization of 40 is 2 to the third power, because you have 2 times 2 times 2. I can write it out too as well, times 5. So if you take 2 times 2 times 3 times 5, you get 40. And it's called the prime factorization because those are all prime numbers. So prime factorization is as factored as any quantity can get. All right. I can certainly, if you're talking about positive whole numbers, okay? Because if I go any further, I would just be adding like a 1 to this, which doesn't really tell us any more information. Now you can prime factorize numbers, but you can also prime factorize polynomials. And that's what we're going to be focusing on this chapter since we are in algebra questions. So the first step of factorization is factoring out, before we do the snowflake method and things that you guys probably remember as factoring if you have done it, you have to know how to factor out what's called the greatest common factor. Because if you don't do this, it makes everything else more difficult, and then your final answer won't be fully factored or prime factorized. So the first step is find the greatest common factor for the coefficients. So the greatest common factor is the largest factor that they have in common. Or I think of it as the largest number that goes into 15 and that goes into 9. So what would that be? Do you think? 3. Good. 3 is the largest number that goes into 15 evenly and goes into 9 evenly. So in other words, 3 is the largest factor of 15 and 9. So the first step was find the greatest common factor for the coefficients. The second step is you look at the powers. So here they both have x's. So it's going to be 3x and the smallest power of common variables. So they both have the common variable of x. Yes. Yes. Because 2 is the smallest power that shows up. So this is the GCF, or the greatest common factor. Greatest common factor. And what that means is I can divide 15 by x squared and get a whole number where the power is positive. If I divide 15 by 3x squared, you guys see that I get 5. And if I divide 9 by 3x squared, what would I get? 3x. But they're all whole numbers, and all the powers of x are positive. So it's the biggest number that you can divide into these and get a positive whole number, or a whole number, and then also exponents that are positive. Because if I went higher, like x cubed, then this one would have too many x's on the bottom. It would be too large, too many x's. Right? So that's my GCF. Now the whole reason you find your GCF is so you can be able to factor out the GCF. But sometimes you'll have to do it with many, many terms. So the first thing we're going to look at is the numbers. I want you in your head to think about what is the highest number that goes into 12, that goes into 30, and goes into 42. That means 6. Does anyone go higher than 6? Nice job. So 6 goes into 12 evenly, goes into 30, and goes into 42 evenly. Now, do they all have x's? Okay, what's the lowest power that all of them have? Yes. 2. So it's 6x squared. Do they all have y's? Yeah. What is the highest power, the lowest power amongst the three of them, I should probably say. Charlie? 1. That's y to the 1. Do they all have z's? No. So z is not a common factor. So your GCF is 6x squared y to the 1. And if I take this, and let me group it. If I take this and divide this by this, do you see how everything would end up on the top? I have 2y. If I divide into here, I have 5z. And if I divide here into here, I have 7x. But it works for all of them. I don't end up with anything in the denominator. And it's as high as it can be as well. Okay, questions on that? Now, the whole reason we find GCFs is so we can factor out a greatest common factor. It's the first step in factoring, even when we start factoring our trinomials, which is like what people normally remember when they factor. So what you have to ask yourself first is, what is the GCF? So can anyone tell me what the GCF would be for this one? Isabel? And how about the variables?
Oh, 5A.
5A. Good. Now, the way I think of factoring out the GCF is it's like distributing in reverse. So I have to figure out what I distribute 5A into to get this. In other words, 5A times what is 25A squared? What do you think, Brendan J?
5A.
5A. Does that seem right? You multiply the 5A times the 5A to get the 25A squared. Yeah. Now I'm going to bring down the plus. Then you do 5A times what is 40A to Lisa? So this times something is 40A. What's that? So 5A times something is 40A. What is that something? 8. Good. Do you need any A's? No. No, because you already have it. Good. So there we go. You guys have factored, get out of the way. You guys have factored out the greatest common factor. The greatest common factor was 5A. So this is factored because you now have written it as a product. Just like writing 6 is 2 times 3, you wrote 25A squared plus 40A as 5A times 5A plus 8. You have factored. All right, you have pulled it apart into 2 smaller quantities. Questions? So we have x squared y to the 5th plus 9x to the 6th y cubed. So Isaac, can you help me out with what my GCF would be?
The x squared y cubed.
What do you guys think? Does that sound right? And now be x squared y cubed times what would give me x squared y to the 5th?
1.
Y squared. What do you guys think about that? And then Denise, how about the second one? The second one I need to be 9x to the 6th y cubed.
9 times.
with those exponents when we multiply them?
Right. Should be x to the fourth and
And the way you check, you don't even need the back of the book. You can just remultiply it, see if you got the same thing. All right. The only issue is you have to make sure you took out the greatest common factor. Because if you take out something lower, you'll still get the right answer, but it won't be the greatest common factor. Okay, these are the, in my mind, the tricky ones. It's harder to see. Ava, do you see what the greatest common factor would be for this one? Yeah, it's trickier. Now this is one variable cluster. That's what I call them. Not a technical term. This is another variable cluster. What do each variable cluster have in common? Even more. X plus 2. Do you see how they both have an x plus 2 with them? So you can factor out a binomial. You can factor out an x plus 2. Even though it's not just a monomial, that's all we've factored out thus far, but you can factor out the x plus 2. Now, Amelia, what would be left from this first cluster? X, good. And Brendan, what would be left with the second cluster?
3.
3. Okay. Good. Now, take a look at that, see if that makes sense to you. I look at it as kind of like a vacuum, like sucking out the x plus 2s. And I'm sorry if that was too much for you right now. That's just my brain thinks of it that way. And what's left? If you take an x plus 2, all that is left here is x. If you take out an x plus 2, all that left is here is a 3. Yes?
if you said in parentheses, instead of one of them having a 2, it had a 3, so it was x plus 3 and then the other one x plus 2, then how would you do that?
You could not, they wouldn't have it in common. So the reason you could take x plus 2 out is because they both had the x plus 2. But if one has x plus 2 and one has x plus 5, that's not a common factor, so you can't take it out. Not everything is factorable. Just like 19 is not factorable. I always like when my age is factorable. It makes me happy. I'm going to a prime number next. What's the prime number? Somewhere between 17 and another number. Yeah, sure, 100. Whatever it is. All right.
I will.
Watch. Okay.
1990.
That's way too early.
You're guessing my birth?
Yeah.
1990.
1990. That should be like my 20s.
That would be. I'm thinking what I was doing in 1990. I'm sure not getting more. Yeah. No.
Wait, that's too young?
Yeah.
Okay, so.
Okay, we'll let you do that now.
2018. 85.
Years old? No.
It's the 1973.
Okay, so we're going a lot lower than 90. So I'll say it's between those 2 years. I can
1975.
I can give you a really good hint.
It's a prime number.
A really good hint.
Is it a prime number?
She's going through.
Is that a good one?
I am going to a prime number. That's not a great hint. I mean, maybe it is, but
No.
it's not super specific. But I can give you a really good hint when we're done.
1979.
So
Well, you're finished, so it should
I'm
be-
enjoying though your guesses, Denise. Not as much as Navnee's. But that's all right. I won't hold it against you. So Amelia, what is the GCF for these? Yeah. So the GCF is 3, and if you factor out the 3, what do you left?
X and then minus Y.
X minus Y. So if we look at the directions, the first part says factor out the GCF, which is what Amelia did. Now, we're going to factor out the opposite. So Damian, what's the opposite of the 3? Negative 3. And Brendan, okay, already. Am I in DJ?
Yeah.
Yeah. So DJ, if I factor out negative 3, which is not the GCF, you guys need to pay attention to this, which is not the GCF, it's the opposite of the GCF, and I'll explain why this is important momentarily. If I factor out negative 3, what would I have to have on the inside? Well, that's what we got when we factored out positive 3.
Oh, negative.
Okay, so the way you check to see if DJ is right, if you distribute that negative 3 in, do you get what you started with?
Yeah.
Or we get negative 3 times negative x is positive 3x. Negative 3 times y is right there. Now, I said I would explain why this is important. Sometimes you come upon a fraction where you're going to have something in the numerator and something in the denominator that you can cancel. But what if what's in the denominator is not x minus y, but it's y minus x? Because this really is just y minus x. If you reverse this, it's y minus x. If you factor out the opposite, you get the opposite of what that was. So sometimes you need the opposite. And so you can factor that out when it makes sense to. But the GCF is, yes. So we're just all of this is being recorded, which I'm sure is amusing. Remember this.
Oh, no.
I have a